thank you for being here today. We are sorry about the technical issue that we're having at the beginning, because yesterday normally we did the test, everything was fine. Even earlier we connected, but we didn't have a chance to try again. But we really apologize for that. Be our first experience through this process that we are trying to promote our new technology, VMF. So I would like to thank everyone for being here today, for joining us today. So we are ready to start. My name is Blaise Mempo. I'm the African Business Development Lead for Danvern. So I then also solution for green building. I mostly focus on green building solution. I'm based in the UK. So we are tremendously excited that we are offering this webinar with my colleague Dean Damit Navod from Bulgaria. He's based in headquarters in Bulgaria. So normally I will kick off first the session, then I will turn over to him that we're going to present the overview of the technology, and then we have a kind of presentation again on Edge, and after that we can have the open session. But this webinar will be recorded. I just want to remind that concerning the webinar, I want just to remind that this webinar is being recorded, and then the material will be shared soon. A few hours later, when everything will be ready to be distributed. Also, we are pleased that you can use during the presentation, feel free please to use the chat board to the chat feature of your screen, where you can ask questions, because at the end we will be saved as us, my colleague and I. We will now go through, and then we together moderate and answer all the questions that you are maybe ask about the session, about the technology, or about maybe Edge, how to achieve the better rate with Edge also. So also at the end of this webinar, after we've done all the presentation, before we turn into question and answer, I'll give you the possibility also to participate in terms of we have an express of interest that we prepare a formula that you can also fill out. Maybe we can carry on through email that we might fill out to see if we have any project that we can pilot a VMF on. So yes, so I will now pass over to my colleague. Before that, I just want to present the short agenda that we have today. Unfortunately, we have a little delay. So my colleague will do the overview of Danvern, the company, and then Danvern, the VMF technology and its function. After that, also I will now go into align the VMF with the H measure, how the VMF function align with H measure, the benefit of using VMF for your project. And then we will, like I said, we have a QA and open this discussion for maybe less 10 or 15 minutes, and then we need the possibility we can conclude. So before I go any further, I want to set the scene. I want us to understand where we are, because the challenge we're trying to complete here, I'm trying to align here with the VMF. What we're trying to align here with VMF is about helping building project up the new or the world vision, which is going net zero by 2050. We can just confirm that VMF in that direction. We are really in line with those vision, with the agreement, with everything. I mean, the Paris Agreement, everything. We are really in line with it. Now, if we look at a building, the power, the HVAC system represents for most commercial buildings at least 38 to 55% of energy consumption. So for people, if we look now, also we are talking about the golden age of green building certification and rating system. That's the world now. Everybody look at that direction, because the green finance, green opportunity finance in green, everybody looking at that direction. And Edge has been proved to be positioned. There's a boom now around Edge. And then Edge also, because why is one of the certification system who's directly connected with finance and return on investment. And if you are looking to achieve that vision I just mentioned to net zero, we need to have a proper technology. We need to think about how to look at the real challenge, which is achieving the target while staying within the budget. So we need a technology who can help us to achieve at least 5 or 7 functions with a very affordable cost. That we think that VMF is setting the pace to that direction. So now I will pass on to my colleague who help you normally to present, like I said, the overview of Damben and then the VMS technology. Unfortunately, you cannot. You have an issue with connection, so I'm going to connect from here. I'm going to share from here.
Yeah. Hello, everyone. Hopefully, you hear me well. I would like to say welcome to our seminar, and I'm very proud and privileged to be co-hosting that seminar with all of you experts from literally all over the world. Today, this seminar, it's about technology. So at the moment, I would put very few words about our company, who we are. We are company Damvent. It's a 100% private-owned technology company from the HVAC field. I repeat, we consider ourselves a technology company because we develop and we create technologies. And we are from Bulgaria. And for more information, you can visit our website, damvent.com. The second thing I would mention is the importance of being from Bulgaria. I don't know if you know where Bulgaria is it's located geographically, but the importance of Bulgaria is the fact that our tiny, small country lies in a very wide temperature region. So basically in our country, we have temperatures in the winter down to minus 25 degrees, and we have temperatures in the summer going up to 42, 43 degrees. At the same time, Bulgaria is located on the Black Sea, so in summertime, we also have a very good experience with average to high humidity. So Bulgaria is a perfect spot and perfect country to develop and to create such technology that can cover most of the climates in the world. The next important fact is when we speak and talk about new concepts, what you normally know about concepts is that manufacturers talk about concepts when they have some kind of future ideas and they are planning to manifest those ideas in the next, let's say, 4 or 5 years. This is how it works normally in the technology world. But in our case, we took the reversed approach. So the technology, the VMF technology we are talking about today is developed and designed 7 years ago. And at the moment, this is actually ready to go technology. It's not something, maybe it's something new for us, but not for you, but not for us, because we have already 7 years of experience and testing of this technology at that diverse climate in Bulgaria. Through that period of time, VMF has gone through countless upgrades of both as a system and as a unit. As a system, we had 3 to 4 major upgrades. As a unit, we have 6 or 7 versions of the unit. So I repeat, this is a concept that is ready to work even at the moment. The next important question I would raise is what made us develop VMF? The existing problems in the HVAC worldwide made us create VMF. And I will mention just few of those major problems that we see, and hopefully you have faced some of them in your region too. So the situation that we see at the moment is that there is no single common or unified system or solution that can provide all necessary or main functionalities for closed condition rooms. This is cooling, heating, ventilation, sanitary hot water, and humidity control. There are singular products which combined together can make a system that can cover some of those functionalities, but in a very inefficient and very cost-efficient way. The second important problem that we see is worldwide, there is a basic misunderstanding of what HVAC means. For most of the people, for most of end users, even for specialists in the HVAC field, HVAC is a one word and supposed to be one system, but unfortunately is not. These are separate subsystems. There are huge areas of the world where, for example, ventilation is completely missing, or it's good to have, so it's not a must. End users very often do not make any difference and do not realize the need of both systems, heating and cooling and ventilation together. Also, ventilation is very often switched off for energy savings. The separate products to work as a system, they require top control automation system, normally called BMS. The different products means different suppliers, different companies, and different responsibilities. But when a real problem on project arises, very often we see transferring responsibility from one company to another. And another problem that we see worldwide is the quality of the design of the HVAC projects worldwide is going lower and lower. We mainly, from our point of a manufacturer and technology company, and mainly exporter, working in many different countries in EU, outside EU, we see either undersized or heavily oversized HVAC projects. These are just the very main problems that we see, and these problems they forced us to develop the VMF concept. So I will start with a short description of what is VMF. Blaise, can you go up a little bit on the first page? Thank you. A little bit lower, just to see the main functionalities. Yeah, thank you. So VMF as a meaning is a variable, oh, it's too big, variable multi-fluid concept. Not multi, but multi, because we have variable fresh air, variable refrigerant, and variable water all at the same time in one unit. As a description, VMF or categorization, VMF is a hybrid. Very often you will be asked, what is VMF? Is it a VRF? No, it's not a VRF. Is it a chiller or heat pump? Yes and no, it's not. Is it an air handling unit? Yes and no. So VMF is a hybrid. And we have categorized it as a commercial air to water heat pump plus ventilation and humidity, relative humidity control. So with our goal was with just one unit to cover all 5 main functionalities that are required for every project worldwide. This is obviously space heating, space cooling, sanitary hot water, 100% fresh air or ventilation, and humidity control in summer, in cooling. Together with those 5 functionalities, we add another one, very important, which is the integrated building management system, or in our case called energy management system, because it's a higher level system that control the whole concept. I would go for the main function, for the main advantages of Blaise, could you go on the next page, please? The scheme. Functional diagram of the VMF concept, where you can see all the main components or players in our concept. The main unit, the internal units, the plant room. Here you can see all the air connections, all the water connections, electrical and communication connections. But in generally, what you see at the moment on the screen, it's not only a functional diagram, but this is also the user screen of our energy management system, where the end user can directly manage and control his own system. This is something that almost does not exist at the moment in the world as a single concept and control system. Later we will go back to the energy management system and we'll discuss it in details. Now I will go for the main advantages of the system. Can you scroll down, please? Yeah, a little bit. So the first and most important, as this was our goal, was to create and design all-in-one unit. So in a single piece monoblock unit, to be replacing the 3 traditional units: external condensing or VRF unit, the ventilation unit or air handling unit, the dehumidification unit, the unit that produced sanitary hot water. The second very important advantage of that concept is on your right side, and this is the reason why we are here today. It's a system that is designed to work at ambient temperatures down from -30 going up to +50 degrees. The idea is, we as a technology company, we have never been producing products or solutions that are limited to a certain climate area of the world. So we have always been producing solutions that can cover the maximum possible range. So I'm very glad that today here we have people from all over the world with different climates, and we can proudly say we can cover with our concept those climate conditions. The next very important advantage of this concept is obviously the energy saving and energy consumption. And based on our extensive testings in the last 7 years, we can proudly say that VMF, it's 50 to 100%, has 50 to 100% lower energy consumption comparing to the best VRF systems in combination with air handling units. And at the end of my technical presentation, I will show you a technical calculation for a city in Europe. Another very important advantage is the simultaneously heating and cooling in different rooms. And this is done not with 3 pipe system like with the VRFs. This is done very simply with a 2-pipe water system. I repeat, simultaneously heating and cooling in different rooms with a 2-pipe system. 50 to 100% less footprint for installation versus VRF and air handling units. Very compact, all-in-one unit. Basically plug and play, ready to go. No additional, it's not a split system, it's all in one. Very important, no CO2 control in the rooms, and always works with maximum fresh air quantity. This is absolutely the opposite of all systems at the moment on every market. They're all trying through the CO2 content to basically limit the ventilation to achieve some energy savings. And our philosophy is completely the opposite. VMF is always working with 100% fresh air all the time at maximum load without any CO2 control at minimum costs. This is the key word, at 100% fresh air at all times at minimum costs. Another very important feature of the concept is this is 100% water system. Very important. You know what happens worldwide with the refrigerants. I'm not going into that subject because at the moment it's very still messy and unclear what will happen. But the direction is clear. Everyone wants to reduce or basically get rid of the refrigerants in the building. So this is 100% water system, and there is no refrigerant within the building. All the refrigerant is in the external units outside. And another very important thing is when we talk about water system is the fact that VMF works with extremely efficient water temperatures. Normally, VRF systems work with refrigerant temperatures in cooling mode of around 7 to 10 degrees. The normal chiller installation with fan coils work with the water temperatures of 7 to 12 degrees. And VMF work with an average water temperature of 18 to 20 degrees in cooling mode. In heating mode, it's the same. The normal systems, the DX system work 45 degrees in condensation. The water system works either 50 to 45 or 45 to 40 degrees, but VMF works with average 35 degrees temperature in heating, which is very close to underfloor heating. Next, very important feature. This is a concept with centralized automatic room control. What that means? That means that at the moment, most of the systems you're working with and you're familiar with, they allow the user in the room to change temperature, to change fan speed, to switch modes between heating and cooling. VMF does that absolutely automatically. All the processes, all the modes are absolutely automatical, and the temperature that is set up in the room is changed by either the owner of the building or the operator of the system, centralized. That is much better for energy saving and for stability of the system. I repeat again, this is a two-pipe water system, and because of its simplicity, the service and maintenance of the VMF concept is less than any existing or well-known system in the world. Additional advantages is we are very confident that we have the lowest refrigerant quantity, kilogram per capacity per kilowatt, versus any of the existing systems, either VRF or chillers. Here it's written 12 kilos, but it's even less. It's 10 kilos. There is no length and height limitations between the external unit and the internal units. There are separate circulation pumps for each floor. Non-stop work of the system during frost forming conditions. There is only one automation master controller. So basically, VMF do not need BMS for the HVAC part. We recover heat, cool, and humidity through the extract air from the rooms all over the year, which brings us to much higher COP values of the systems. No maintenance for coils and fans because they're located inside the unit, no refrigerant noise indoors, and significantly less electronics versus the classic system of condensing unit and air handling unit. Just to summarize, I will say that our energy savings and energy consumption of VMF, it's outstanding, and there are few reasons why we can say we have 50 to 100% less than all of the system. The first one is the direct expansion system or the VRF systems. They lose up to 30% of their capacity only for transporting the refrigerant. And this is one of the reasons why those systems are heavily oversized. VMF works in a combination of ambient air, like any of the well-known heat pumps, but also with a lot of extract air from the room. The average water temperatures of VMF, I already mentioned, very highly efficient, 18 to 20 degrees in cooling, 35 degrees in heating. And also, last but not least, comparing to some other systems, like especially with the VRFs, which are direct heating or cooling systems, which means that they directly bring the heat or cold to the rooms, VMF actually works with the heat and cool accumulators, buffer tank accumulators, which all those 4 or 5 additional measures gives us the possibility to make those significant energy savings of 50 to 100%. Then very important for you will be to hear few words about the applications. This on your right side. Yes, basically, VMF is a concept that is designed to fit any, I repeat, any project with any possible application in any part of the world. So here are just some of them mentioned: offices, hotels, hospitals, private mansions, fitness centers, gas stations, fast food and restaurants, superstores, swimming pools, industrial projects, retrofit buildings, and whenever 100% fresh air plus heating, cooling, and sanitary hot water is required. This is very important because this is a very flexible concept and really can fit to any possible project. And we know that because we are quoting such projects in different countries and in absolutely with different applications, starting from hospitals, going through swimming pools, to fitness centers, to office buildings and hotels. The model range of VMF is very simple. VMF has only 2 models. The big one that is the major one goes up to 58-60 kilowatts in cooling mode at reference conditions. This means plus 35 degrees, and up to 4.2 thousand cubic meters per hour. The important here is that with that size of a unit, basically we can design any project starting from one single unit, going up for projects up and above 1 megawatt in capacity. And we have already quoted such project. That means that whenever we need more than 60 kilowatt, we start adding more units and more systems. And we are very flexible in that direction because we can combine, the systems can work absolutely separately. If this, let's say it's a high building with different floors, or 3, 4, 5 units can work with one heat cool center. So we are very flexible to cover from a very small to a very, very large capacities. This is very important. I repeat, VMF is designed for any climate, any application, in any size. Blaise, can you go a little bit lower maybe? I want to say a few words. Yes, or maybe higher. We need to find the internal units. Yes, yes, this part. Very important is the indoor climate, how we achieve comfort. I mentioned in the beginning that we have gone through several hardware upgrades of this concept, and our latest one is that VMF goes always go together with the active chilled beams. For your information, in the beginning we have started with fan coils. We're very familiar with them, with other type of radiant panels, but we do believe that the active chilled beams are the best in terms of many things. And I can start with the fact that they offer not only temperature control, but also relative humidity control in the room during the summer or cooling mode. And we achieve that through a fresh air dew point control. At the moment, at least me, I don't know if there is a system, a concept that basically do cooling and humidity control with one unit. Very important. The active chilled beams, they work with 100% hygienic fresh air, which comparing to the traditional based fan coils or cassettes, VRF cassettes, they work with 100% recirculation or a very, very small percentage of fresh air. The active chilled beams has the best feel-good factor in the HVAC, which means that the comfort is significantly better with consistent temperatures, without any drafts. This is basically with a very, very low speeds. Another important feature is there is no condensate in the rooms, because all the condensate is removed in the VMF outside the building. There is no noise because no rotating parts, no motors inside, no wiring and cables into the rooms, no electronic, no need of supply grills into the room because we introduce the fresh air directly into the chilled beams. It also has an excellent design and very often is an interior element, more energy efficient and energy savings than all the traditional water systems due to the better water temperature that I already mentioned. It always works with 100% fresh air. And last but not least, practically, those active chilled beams, they do not require any maintenance in the room. No motors, no filters, no electronics, no wires, nothing. Maybe once per year, cleaning with a regular vacuum cleaner, and that's absolutely enough. So the active chilled beams, they are not only a cooling device, they're also heating device. So it serves very well in heating mode as well, because don't forget that we pressure the air through that device. So we have no problem to put down the air in the working comfort zone. And once again, active chilled beams are very important and integral part of the VMF concept. Can you go a little bit slower, Blaise? There is a full technical page with all the data for both sizes of VMF, and at the moment I will not pay any attention on that. You can check it by yourself, and if you have any questions, you can come back to us later with email or comments. But I will spend some time on the last page on this catalog, where we made a case study for a certain city with average climate, and because we are in EU, this is a city in EU. This is the city of Vienna. Blaise, can you reduce it a little bit, just a little bit more? A little bit more, 150%, I think will be enough.
Wonderful.
Yes, thank you. Why we did that case study? To show you how we calculate the yearly energy consumption of a single VMF unit. And for your information, this case study can be done for any other city around the world. After we finish our presentation, Blaise will also tell that to you, that once you have an interest on a potential project, you just give us the name of your city, and we will make the same energy analysis for your city. So in that case, this is Vienna, which we consider as an average EU climate, which means not the lowest, not the highest ambient temperatures. The importance was to show a city with basically all seasons. And very important is to see that ambient temperatures, and we have the so-called bin hours. Bin hours are the ambient, the hours at each temperature. So it's very clear that the lowest temperature over there, it's -8. The highest is 34. So we have heating mode, we have cooling mode, we have free cooling and ventilation mode, which is extremely important for VMF, and you will understand now why. The energy consumption, we have calculated it in two modes. The energy consumption for yearly energy consumption for heating, cooling, ventilation, and humidity control is calculated, and it's 48,200 kilowatt hours, let's say. Then separately, we have calculated the yearly energy consumption in VMF unit working only for domestic hot water mode at a set point of 45 degrees. And the energy consumption over there is 46,000, a little bit more than 46,000 kilowatt hours. Then, very important is for every project, whenever we have both heating, cooling, ventilation, and sanitary hot water, we have the so-called coefficient of usage. That means, Blaise, can you scroll down a little bit? Coefficient of usage, we describe it as a percentage of the yearly operating hours in which VMF is working prioritized either in domestic hot water or heat-cool mode. So for most of the projects, in this particular case, we have taken an office building, and for office building, the priority is always heating and cooling and ventilation. So we have put 80% for that and only 20% for hot water, because in office buildings, normally it's usually only tap water for washing hands. So when we put those coefficients, the total energy consumption of VMF becomes 47,800 almost kilowatt hours per year. Then, very important is the next parameter, yearly power input, average in kilowatts per hour. So this energy consumption of 48,000 almost, when we divide it to the total amount of hours per year, we get that the VMF will be working with average of 5.46 kilowatts per hour, which for a capacity of that size is absolutely nothing. And to prove that, below you can see the COP, SCOP, SCR numbers. For those who are not familiar, this is the main energy indicator for every heat pump. SCOP means seasonal coefficient of performance. SCR means seasonal energy efficiency ratio. So SER and COP, the average one yearly for heating, cooling, and ventilation is 6.16. The SCOP, when we work in hot water mode at 45 degrees, is 3.7, but the average, including everything, cooling, heating, ventilation, humidity control, hot water, is 5.67, which at the moment cannot be achieved by any single product or system worldwide. This case was important to show you how we calculate and how we measure the energy efficiency, the energy savings of VMF, and the fact that we can do a similar case study for your city as well if you have a potential project. And last, just a few words on the energy management system. Please, can you? So in the beginning of the technical presentation, I mentioned that extremely important part of VMF is the energy management system. What is the difference between the energy management and the building management system? The difference is that integral part of VMF is a built-in energy meter with which we can measure the energy consumption of the whole system in a real time. But not only that, but also to record those values. So this is the user screen, I repeat, and you see the energy performance of the system, where on the left side, energy consumption in kilowatt hours, VMF total, where it's written, this is the energy coming directly from the energy meter. Then separately, we cover and measure the energy of the pumps, and we can provide the total energy consumption of the system at any single moment. This is also a part, Blaise will go through that in his presentation with Edge, but we did that since the very beginning 7 years ago without even knowing what is Edge. So this measure for energy monitoring and energy recording and measuring, it is part of VMF since the very beginning. And I think I will stop for now on my part to give time for Blaise to unveil his presentation of how VMF fits to Edge requirements. And hopefully, I really hope at the end, we will be discussing and answering your questions. So thank you for now, and I will join you later.
Thank you very much. Thank you, Dan, for this presentation. Yeah, now I just want to present how VMF is connected with Edge, how we can use as an Edge expert, how we can use VMF to achieve some of the high rate in terms of Edge. So what I'm going to do, I just because we don't have enough time left, I'm going just to go into kind of a small case study that I developed, like kind of retail, where I plan to put all the feature of Edge, all the feature of the VMF into Edge. to see how it can impact the result. And you can see on the screen, edge, the VMF is that have a big factor. How does it factor like into a certification? If I can say that way, you can put that question that way. You can put the question that way. Edge measure, only that edge measure, those 7 measures align with the VMF function with the cooling. The variable speed because we vary all the liquid around the VMF system, water, air, and the refrigerant also. All those are variable. So the variable speed driver also applied. And fresh air preheating because there's a heat recovery system like he already explained during the presentation. We also have space heating that and then domestic hot water we also clearly explained during the technical part. Economizer we also explained that there's some free cooling that we collect in the appropriate climate. So when the temperature outside is right, we can also just supply the fresh air in. And the smart meter, the last one you explained, and the low impact refrigerant. That one can achieve only one unit, you can achieve that in edge, which is kind of like you mentioned before. Or you need to achieve this same, those 8 measures. Sometimes you need to combine 3 or 4 technology to arrive there, to arrive in this same level. So the small case study I did, I based on the energy efficiency side of the edge, which is that kind of based on the looking at first of all at the basic requirement. The asterisk part of the measure that we have to provide information. I thought just the base case and see what you can tell me, and then how by adding the function of the different function of the VMF where I can reach as energy saving, water and energy savings. So the base case study we went through, it was I took a retail based in South Africa, where you can see when you calculate only the base measure with the blue one. The blue one is a kind of base information that we put in, based on the regulation, also local regulation. We achieve only 80% that we didn't achieve. We didn't meet the edge requirement yet, which we supposed to be 20% energy saving. Now they also keep the boiler with the conventional also. Based on the local regulation, is the boiler 100% electricity use. But the other requirement was okay. We could achieve the basic also requirement. The basic conventional requirement we can achieve material and water, because the basic even local construction, when you reduce only a bit, you can still achieve. But our challenge is still around energy, where we want to achieve at least 40% with a net zero ready, because the aim to achieve net zero in the future. So also I assume, because most projects, even the large project, sometimes we don't consider heating, which you can clearly see here that if we don't put the heating in South Africa, we need space heating. So the South Africa region was the really appropriate area to implement all the function of the VMF. That's what we try to implement here. So if I take that into consideration, only at this stage, since I need to move first of all from from not achieving edge to achieve edge by using only the basic, because that's why you're going to say, okay, I'm only edge certified. I don't need VMF I don't have to use the VMF. Yeah, we don't have to use the VMF. That's what I want to prove here. You can use the only basic energy Latin, Latin efficient Latin, internal and external, then you can still achieve edge certified. But the challenge still there. If somebody want to achieve the edge advanced, most edge expert online here know that to achieve edge advanced, most of the time we need solar system. Solar system is you need to design the solar system to achieve edge advanced. Sometimes very challenging in certain area. Now that was the VMF really help. Now if you look at it, that was the VMF really help, because if I put in the VMF function, when I put all the VMF function that you can see here, the variable C, the fresh air, the space heating, domestic hot water, economizer, smart, and low, you can easily achieve 54.83% with this commercial building. You see, that's the with only one technology. In all what I have to supply to the auditor is only that document that I'm going to show to you shortly. So With a VMS system, only with one unit, you can achieve a lot with edge. Mostly people looking at advanced or looking for really high efficiency. I mean, in terms of achieving net zero, in terms of looking at zero in the future, because we have to be 40% energy efficient. So that be what I wanted to present to you. As you can see, when I put in all the parameters and all the feature of the VMS, I can easily achieve. Edge advanced. Yeah, because I want to let a lot of time for us to discuss anybody has a question. Now, I said you can see, and I consider the heating, the spacing thing from based on wherever you can see now it become one no virtual energy anymore, because I consider that as a spacing thing now. Or if you want, normally, yes, you can use reverse heat pump. It will still cost money, but with the edge, with the VMF, we have already that one integrated. I mean, the space heating function is already integrated, which is a great advantage also. Now, for the next step that we are looking for now is for us to work together. We have a possibility to develop more your knowledge. Yeah, we understand this is a very few hours to understand to gather a lot of information in one go. So we are opening the possibility to do that. Accredited professional who are edge expert who understand very well VMF. This was only the introduction, where we can have a proper set to do a proper training, go through different VMF, and they know how to model the VMF on edge, and we do some proper modeling through edge. Use the edge so it can easily be used for your project. If you have challenge, you are facing challenges. You can see on this table it's clearly that if we go for the small capacity, we can achieve 527 or 523 according to the capacity. We have also a lot of airflow. Yeah, we don't need two systems, because most of the time to have a very good ventilation system, you also need you also have air under unit and the VMF to control the temperature, to treat the air. But here, only one unit, you already have that. You don't need again to install a separate one with a very low power consumption. As you can see here, we have we achieve a good COP here is down here. The COP is down here. The COP here. A very good COP. While also the requirement in edge expect you provide the COP. Now another one is the second measure is variable speed drivers, which I mentioned earlier. You can see all those pumps are available. The compressor, all of them are available. You can see air, water, and refrigerant also variable on the system. Those how can be modeled. Yeah, that the way can be modeled on edge. Also explained on the document that we already shared with you. I'm going to share it again. Yeah, how the different components will have been modeled through. I mean, who have been where there's a VSD installed. And now the second feature is the free air. Also, air, we have we have the heat recovery system here installed, and then the air-to-air plate heat exchanger total heat recovery where we install. So in edge, how to model that in edge, because edge also asks for you to provide the type of heat recovery. So we have a total heat recovery. That what we have. Edge also require that, and then the performance also on this document is included. So we have a very nice performance this year. The performance for cool recovery, that's the efficiency in terms of humidity and the term of temperature also. We have this also. You can easily just input down the edge, get you the good answer. When I model, those information I use to model the one actually you saw, the result you saw. So that's it. And then the second function also explained in this document is the heat measure. I mean, in terms of space heating. Well, also the same requirement asks you for how to model this part on edge. Asks you the input to describe the improved case, also the E distribution in the building, and then the installation capacity. Good COP also 474 and then 511 for the bigger capacity. So we have a very good way to, I mean, the good efficiency here in terms of COP to model on edge. And the next function is hot water. Clearly on there, you can see that we have a clear the buffer installed. everything is there. Then it come from heat pump, so we can clearly say that the heat pump water heater is installed. And then I think the Macaulay clearly explained the functionality that how it works. But in terms of edge, the COP edge, this is a COP 296, depend on the climate also. But this is what we are having now. The climate that we model is 290, close to 3, which is very good also for hot water. Compared to that, in that case, you model the edge with 100% heat pump, and then you choose this COP. You don't need only to provide only this document for all the 8 major. Use this document only to justify those requirements in terms of technical. And the next function with the economizer also. Here we have the type of economizer that we have. It can be modeled here is the air one. You can see it's the air economizer we install. Air economizer type is the one. Is the requirement of Edge also. Edge asks you to specify which type of air economizer you have. So here for Edge air economizer type we install, and then the free cooling we can explain also. That's it. And the last, not the last, maybe the smart meter also. We have a smart meter quite. It contribute because normally we have Edge require that Edge requirement as the smart meter to be installed to all the energy usage, but this contribute to you don't need to separate smart meter again for the cooling system, for the HVAC system, for the HVAC system. I mean, you don't need any other smart meter because this one fulfill the Edge requirement already. And last but not the least is the refrigerant now. It's the refrigerant part. With a camera, because let's say it's only maybe 10, it's only 10 kilo. You can see for the small capacity 28, and then a 10 also for the bigger one. So really the lot of low impact refrigerant on the project. So like I said, we give the possibility that we can discuss again. We can discuss again. This is only the kind of introduction, and the people who have interest, I just send the express of interest formula to you. You can fill out, and then we can discuss further. If there's any project, we can discuss further. So now we are open to question and answer, to QA session.
Yeah. Thank you, Blaise. So hopefully some of you have questions. We are ready to answer.
This is our contact, just in case. Yeah.
Yep. Don't be shy. Just go for whatever question you have.
Yeah, you can open your microphone and speak, please.
Yeah, just I saw one question from someone.
Yeah, somebody. Yeah.
Only beam solution. Honestly, we as I mentioned.
Okay, yeah, I already received it. Also another question. Yeah, sorry. Let me read that question to you. You were trying to ask how do you what's the difference between this technology and the Mitsubishi technology?
Mitsubishi
Hybrid Mitsubishi.
Hybrid VRF. Yeah.
What's the difference?
First of all, hybrid VRF can cover only 3 of those functionalities, which means space heating, space cooling, and eventually sanitary hot water. Hybrid VRF cannot cover ventilation and cannot cover humidity control. That's the first thing. Second of all, hybrid VRF is a three-pipe system.
Okay.
With a lot of
refrigerant in the building.
No, not the VRF with Mitsubishi. Sorry.
What?
Not the hybrid solution with Mitsubishi. You have a box and you have a refrigerant and water.
Yes. We know that. I know hybrid VRF from Mitsubishi. So still, I repeat, first of all, can cover only 3 functionalities maximum. Cannot cover ventilation and humidity control. Second of all, it's more complicated because it's a 3-pipe system, I believe. What else? It's obviously it will be more expensive because of that, because of the three pipe system. Also, I don't think the Mitsubishi of the hybrid VRF of Mitsubishi can work with the water temperatures that we work normally, because they have totally different type of internal units, cassettes again. So they work mainly on recirculation. So there are many differences between that. Hybrid VRF is it's a little bit better technology than the existing VRF technology, because it's not a refrigerant, but it's water. So in that direction, it's a better technology than the VRF. But in terms of functionalities and performance, it's still far away from VMF as a technology. And
So-
also, of course, cannot cover the automation system of. It can cover only the automation system for the hybrid VRF, but it cannot cover the total HVAC system. So there are many differences.
No, but you enter in a big building, you interface with another BMS.
Sorry?
In a big building, you interface with another BMS.
In the big building, yes, you do have BMS, but at what cost you have it?
Yes, but your system, can you interface with other system as well, like a PMS,
Yes,
like for an hotel, for
yes,
example?
absolutely, it can interface, but the difference is that being integrated in a larger BMS, our system will provide a certain parameters. Some of them can be changed, very few of them, and a little bit more of them can be viewed, which means that you cannot change them, because it's a integrated system. But yes, it can be integrated with any existing BMS system.
Or PMS as well?
BMS, yes.
No, PMS, Property Management System.
Also, it's a matter of protocol.
Okay.
It's only about protocol.
It's like a LAN, it's a LAN product or something like this?
Because we are using emboss.
Sorry, I didn't understand the question. What?
Is it a LAN protocol?
No, at the moment we use Modbus, but it can be used. It can be used BACnet. It can be used KNX. Any kind of protocols. The integration between protocols is happening through a communication integrator.
Okay.
So going into any other protocol, it's not a problem.
Okay.
They use emboss,
Modbus is standard at the moment. Yeah. I think in the chat we had some other questions. Let me go back to the first question. Is that only a beam solution? Yes, at the moment we believe that the chill beam is the best one. What is your experience? What do you suggest to have as a solution internally? I think the question is coming from Yvonne.
Yes.
What do you suggest as an internal solution?
Most of the time, you have Carrier. They have also done some beam and fan coil unit solutions.
Yep.
I'm talking about the hospitality business, because in hospitality business, in the standards require to have fan coil unit. Most
fan coil unit?
Yes. In the standards for hotels, from the big company like Marriott, Radisson, Accor, this kind of Hilton.
Yep, there are two ways. We don't fit to their standards, or we will change the standards at some point.
Yeah, yes.
Because fan coils, what is the trend? I will tell you. After the COVID times, what happened is, sorry to ask, which country are you from?
I am in Belgium.
Okay.
But I working quite a lot in Africa as well. Huh?
Okay. So what happened, at least in EU, is after the COVID, the internal climate conditions have changed. A lot of standards are going to be, they are changing at the moment, still not officially, which means that the internal units that are working on recirculation will be avoided in the future. And more fresh air will be introduced into the buildings. Because of the
we use the wheel to the return air handle unit.
Sorry, you use what?
A wheel, heat recover by the wheel.
Yes, heat recovery is a heat recovery, but I mean that fan coil unit or VRF cassettes, these are all units working on 100% recirculation. And with the chilled beam, we work with 100% fresh air. So in terms of comfort, in terms of cleanliness of the room, in terms of microorganism and bacteria, this is much better and higher.
But you use CO2 sensor.
Sarah, sorry?
You use CO2 sensor.
No, we do not use CO2 sensor. We always work on 100% fresh air all the time without CO2 sensor.
Okay.
We don't measure it, we don't follow it, and we don't reduce the ventilation speed. We always work on maximum fresh air.
Yeah, and next question is, what is the cost implication in comparison to other HVAC systems?
Yeah, very good and important question. I would put it that way. If you put on the left side any classic system, and if you put it in the correct way, including the heating and cooling equipment, including the air handling equipment, including the equipment for sanitary hot water, including the BMS system covering that, including all the labor, and on the right side, if you put the VMF will always be a lower investment. How many percent increase in cost? I don't think it will be, depending on which region of the world we are, depending on what is the initial system, how simple or advanced it is. I would say that even if we compare to the very basic system, VMF will be at least at the same level, but obviously with much higher efficiency. Yeah, he's asking for Africa. Maybe Blaise, you can tell that man a little bit more about our first potential projects there, our experience with the costs.
Yeah, the cost was more, to be honest, is more into transportation. But normally, the technology himself was very affordable because he want to achieve the same functionality with what the VMF can allow you to achieve. You need to transport more technology. You need the VRV. You need now the air under unit alone, and you need another VMS alone. All that's kind of cost into the equation. So here, the only main cost was the transportation. When we compare to the conventional one, to be honest, the difference was less than 30%. And he will look at it less than 30%. But when if that project was looking to install the air under unit, because I was looking only about the full functionality, not 5, only full functionality. Normally, when I put all the functionality, including the BMS, we were very far much better. Were cheaper compared to the conventional one.
Yes,
all the functionality.
I repeat again, to compare VMF with any existing system, when we say existing system, you have to put in a list all the equipment. I repeat, the heating and cooling equipment, the air handling equipment for fresh air, the equipment which produce hot water or whatever it is. Then you have to put labor, and then on the top of that you have to put at least some kind of BMS system. When you put all that costs together, we are always better. The key is to make a correct comparison when we compare prices. And also, we should not forget that VMF saves, this is the idea, VMF saves a lot of labor on the project side. VMS is a system that is basically plug and play. When we send the unit, this is a unit ready to go. There is no hot works, no refrigerant charging, nothing. It's ready to work.
You need only the plumber, to
And
install the pipe.
yes, very simple pipe system, very simple duct system. And we do a lot of pre-work here at the factory. So the idea is whenever we go, no matter which part of the world we go, to reduce the installation costs.
I will answer your question, Mr. Okay, do you have any other question, any other comment?
Please throw your questions.
Okay, thank you. He said we will answer his question. It was clear to him now.
I
share the formula just in case you have a project you'd like to pilot on it. We are really happy to discuss with you, to work with you and see how we can implement the VMF on your project and how we can work together. Luckily, because we're working with the manufacturers, so there's a possibility
I would like, when I have the time now till waiting for some more questions, I would like to share some thoughts on the design of this project, how important it is, the design. VMF is a concept that is based on optimized design. That means that in the beginning we give you a guideline for how the design should look like, how many units, how many internal units, capacity, and everything. And VMF is a concept that also saves time in designing, no matter which part of the world that is. So whenever you have a potential project, the first step is to get in contact and start looking at your potential project layouts, drawings. It's always we always start from there. But the importance is that VMF gives a flexibility because we can go on the roof, we can go in aside the building. It's just important to be in a open space. And also with the VMF, I repeat, we can have a decentralized system, which means if this 5,000 square meters spread it on 5 floors, we can have 5 totally separate systems covering independently each floor. Or we can have 5 units covering with a common accumulation center going in the different floors. It gives a great flexibility.
Okay. Thank you very much. I think we reached 1 hour 30 minutes. If there's any follow, we just follow up with the emails, and then, like I said, the form is there. If anybody want, then we'll follow up also with email. And then the presentation will be recorded. So we're going to share later if people want to listen again. And then, yeah, we'll keep in touch by email. We're going to follow up with more information. Then maybe one-to-one also conversation.
Thank you, everyone.
Thank you for your time. Thank you for taking your time.
And hope to see you soon again.
Okay. You take care. Bye-bye. Bye-bye.
Bye-bye.